test 4. Okay, so in class you had this review, but I'm going to go over some of the answers just so you can kind of see where these came from. Again, I'm just going to fill in some things. I'm going to write around this, maybe a little bit, and really just talk through it. Okay, so on this first one, we're talking about, we've got a function with the second derivative given here. So we see this as f prime. Make sure on all of these you're really paying attention to what is the function that's given. Is it f prime, or f double prime? Because it's going to change throughout. In this one, if we're talking about points of inflection, remember points of inflection are where f of x changes concavity, meaning concave up to concave down, or vice versa, but that would be where the second derivative changes sign, so negative to positive or positive to negative. So I made a sign chart down here. I found the zeros here, so I have x equals 0, 3, and 6, and then I made a sign chart. Remember, when you're substituting back in a value between negative infinity and 0, your favorite number, which may be or may or not be my favorite number, when you're plugging those back in, make sure that you're putting them back into f double prime. This one, there's not really anything else to put it into, so you probably won't mess that up, but just something to keep in mind. In the next problem, it says f prime, the derivative of the function f, is shown to the right. So make sure you label that right away. Then I would suggest, as you're reading through these, before you even look at the graph, maybe cover it up, do something, so then you can think, okay, f is decreasing. What does that mean for the graph of f prime? Because that was what was given, f prime. So I would say f prime is less than 0. And then you can see, is that true? So from negative 1 to 1, is f prime less than 0? Remember, this would be positive, this would be negative. Anything above the x-axis positive, below negative. And if I go through these, I can see that from negative 2 to 0, so negative 2 to 0, f prime is positive, which means f is increasing. But all of these other ones just don't make sense. This last one says f is not differentiable at x equals negative 1 and x equals 1. If I'm talking about negative 1 and 1, you might say, well, f isn't differentiable there. What is not differentiable is actually f prime. If I were to find the slope of this graph, which would be the slope of f prime, f double prime would not exist. But f prime already is defined. I can see it's down here and up here. Because this function is continuous, then it would be f is differentiable. So I made a note here that says f prime does not exist, not continuous at x equals 1 and or x equals negative 1 and x equals 1. That would be if I should even say f double prime does not exist if f is not continuous at x equals negative 1 and x equals 1. So, or actually, no, going back. F prime does not exist, meaning f is not differentiable if this function, so if there were a hole here or a hole here, then we could say this. Okay, number 3. In this one, you're thinking about this function f of x, f prime, and f double prime are all negative. So I wrote down before I ever look at the graph, if f of x is negative, that means all y values are below the x-axis. F prime is negative, that means f of x is decreasing. And negative f double prime is less than 0, so that means f of x is concave down. So I go through and I think, okay, let's go through the first one. Negative, f of x is negative. This one's all negative, this one's all negative, this one is, oh no, this one and this one. So immediately cross off D and E because it doesn't meet that first requirement. Next one means that f of x is decreasing. So if I'm talking about decreasing, oh, I see it's increasing here, that one doesn't work. Decreasing, increasing. So actually B is the only one that works at this time. Let's just check, make sure that f of x is concave down, and yep, concave down. In number 4, if we're talking about which of these statements is true, you have to go through and you have to make a sign chart. So f prime of x is greater than 0, f of x is increasing. I can see all of these have something to do with increasing, so that's what I'm checking for. Is f prime greater than 0? So I found the derivative, I factored, found my zeros, and then I made a sign chart. Make sure when you're doing f prime of x here that you're substituting your favorite number in for f prime. So f prime, this one, or this one, or this one, any of those to figure out if f prime is positive or negative. Okay, number 5. Oh, there's always lots of questions on this one. So if you, excuse me. So if you didn't get it, you're not alone. One of the things in here, g of x is continuous. That's nice. And twice differentiable. So even if it didn't say continuous, I would know because it is twice differentiable that it's also continuous. That does not mean we're looking at the second derivative. All this means is you can take the derivative and then take it again. That the derivative and the second derivative are both continuous. They both exist. So here I've got some information. G prime of 1, or negative 1 is equal to negative 2, and G double prime is greater than 0. This one's the one I'm going to use first. G double prime is greater than 0. That means that G prime of x is increasing, and G of x is concave up. So I know some people try to graph these and do some other work, but what I do is I make another column. So in order to find the slope of the tangent line, if we can't find that, what we can do is find the slope of the secant line. So I'm going to estimate. So I made another column for G prime, and then I use the slope formula, like y2 minus y1, so 3 minus 5, is equal to x2, negative 1 minus 2, which would be positive 1, x2 over minus x1. And then I found the slope, and I found this to be negative 2. And then I do the same thing here for these 2 points. And then I did it for this 2, and these 2, and these 2, and these 2, and I did it from all these columns. Because if G double prime is greater than 0, that means G prime is increasing, and I can see this is not increasing. This one, you have to be careful with negatives, but this is not increasing. Negative 1 to negative 3, not increasing. 1 to 3, hey, that one is. This is a possibility, nope. And this one is negative 3.5 to negative 0.5. It's becoming a smaller negative, so yes, it is increasing. Okay, so 2 possibilities at that point, B and E. The other thing says G prime is negative 2. If I look here and, oh wait, sorry, that wasn't the one that was increasing. This one was. This is not increasing. Negative 1 and negative 3, not increasing. There it is, 1 to 3, increasing. If I look here, 1 and 3, negative 2 doesn't make sense to go in between them for negative 2. But over here, negative 3.5 and negative 0.5, yeah, that makes sense. So which of the following could be a table of values? This one works and meets all the requirements. In number 6, I've got picture to the right is graph of f prime. Nice, so it's already labeled. I made sure to know, like, yes, this is f prime. If you need to make it bigger, then do that. But it's asking here, at which of the following values of x does the graph of x have a horizontal tangent, but not a relative min or max? So what I go through and I check and then think about, okay, what does that mean? That means that f prime would not be changing signs. At x equals negative 3, I can see it goes negative, 0, negative again. Ooh, that looks like a winner to me. And that's why I chose this one. At negative 1, I can see that f prime goes from negative to positive, which would be a relative min. And at 1, from positive to negative, which would be a relative max. So the answer is x equals negative 3. Okay, this one you would need a calculator. That's why it says calculator problem on it. You're finding what is the x coordinate of the point of inflection. So you go to y1 and you put this in. Make sure that when you're putting this into your calculator, either you write it as a fraction automatically, or you make sure to put parentheses around this part of it. If you don't put parentheses, your answer is going to be messed up. So what is the x coordinate of the point of inflection? I go here and my graph looks like this. You can zoom in on it, but I can see these values are pretty small. So I didn't do anything, or I made the window so that I could see all of these values of x. I made sure I had a general idea of what the graph looked like, and this is a very rough sketch of mine. And what I can see, if I'm talking about a point of inflection, and you might even want to think through this first. Point of inflection for f of x is where f double prime changes signs, which means that f prime is going to be going from positive to negative or negative to positive. Or, whoa, said that wrong. That's not good. Let's reverse. F double prime changes signs. That means, just so I'm very clear, f double prime is going from positive to negative or negative to positive, which means f prime would be changing from increasing to decreasing, a relative max, or decreasing to increasing. In this one, I can see at x equals 0.473 because I went on my graph, and you can find, if you use second calculate, and then go to maximum. You can push this button. Yeah. And then it will say left bound, right bound. I actually don't have this in. I could do it. So a couple things on this one. You can do the square root of x. Make sure when you divide, you put 1 plus x to the third. Really important. Make sure you close your parentheses. And my window, it looks okay. Oh, maybe not. I can't really see much. So what I'm going to do is I'm going to zoom in so I can see a little bit more of the y values. So how about -2 to 2? Oh, that was a 5. I accidentally wrote 5, but hold on. 2. Okay, that's enough that I can see there's going to be a maximum there. So I write second calc maximum. And then you go left bound. So I'm going to go to left of that place where I can see it being in a max. Right bound. Push enter. And then it says guess. All I'm going to do is push enter again. Hey, I get 0.4725. If I was truncating, I would say 0.472. But because the answer is rounded, I'm going to go with that one. That connection, knowing that the x-coordinate of the point of inflection would be when the second derivative changes signs, but that's when the first derivative is changing from increasing to decreasing or decreasing to increasing. That idea is important for this test, you know. But I feel like that's what we're talking about right now, this test, so. Okay, next one. On this graph, so we're given f prime to the right. So we've got f prime, and so I labeled it because the graph kind of stunk before, but I made it better by labeling it. And I'm using the graph to answer these questions. Are there any values where f of x is not differentiable? This one is one where I feel like some of you are going to try to fight with me and say, no, at x equals 2, x equals 5, and x equals 6. And really, if you want to be technical, 0 and at x equals 8, you would say this function is not differentiable because there's a sharp turn. And the sharp turn part of that is the second part of the two-part definition, I guess, the two requirements for something to be differentiable. 1, to be differentiable, the function has to be continuous. And 2, the limit from the left has to equal the limit from the right of the derivative, meaning nice, smooth curves. But this is asking where f of x, so f of x is not differentiable. See how this is the graph of the derivative f prime? Which means f prime of 2 is 4. F prime of 5 is -2. F prime of 6 is -2. F prime of 8 is 2. F prime of 0 is 1. All of those values exist. So since f prime of x is defined for all values, that means f of x is differentiable. If we were talking about f double prime would not exist at 2, at 5, at 6, meaning f prime would not be differentiable at those locations. And the second one, it says on what intervals is f double prime greater than 0? So again, we have to think through this process. I know, or I'm hoping that you think f double prime is greater than 0, immediately thinking of concavity for f of x. But if I'm thinking concave up for f of x, that doesn't really help me with this graph, f prime. So on f prime, if I want something that is f double prime is greater than 0, this is the slope of f prime. So I want the slope to be greater than 0. And I can see that it happens from 0 to 2 and from 6 to 8, meaning this function is increasing. So if the slope is positive, that means f prime is going to be increasing here and here. If I'm talking about just a horizontal tangents occur when f prime is equal to 0. So I can see that happens at 4 and at x equals 7. In this one, what's the value of f double prime? F double prime of 4 is the slope of the tangent line. And if I can't get the slope of the tangent, actually, I can because these are all straight lines. I was going to say we had to do the slope of the secant line, but we don't even have to estimate. At 4, this is a straight line, so you can find the slope. So old school, y2 minus y1 over x2 minus x1. I am way off the page. I'm pointing to the wrong place. Hope that hasn't been happening for long. There we go. Now I'm back at x equals 4. This is way more effective when I point on the actual page. F double prime of 4 would be the slope of the tangent line at x equals 4. So I do y2 minus y1 over x2 minus x1. If I say f double prime of 8, oh look, it's at the end. I can't find the slope beyond it. I don't know what's happening after here. So f double prime of 8 is undefined because f prime is not differentiable. This is where, again, that definition comes in, that f prime is not continuous at x equals 8. And there are actually some debates on this, depending on which book you're reading, whatever. But this, I want to make sure that you know, in order to be differentiable, the function also has to be continuous. So at x equals 8, it's not. In this one, okay, if g of x is equal to this function, so I've got e of 2x times f of x. That looks like a product to me. Woo, woo, we get to do the product rule. Okay, and f of 2 equals -3. What is the equation of the normal line? Normal line is just the line perpendicular to the tangent. If you ever have any questions on that, let me know. Because the way that it's tested now, from what I've seen, is that it would actually say line perpendicular to the tangent other than normal line, and that just seems pretty wordy to me. But, so I did first times the derivative of the second plus second derivative of the first. The tricky part of this part is, because you're just substituting in, and then you find the slope of the tangent, and then you find the opposite reciprocal. So this was negative, this becomes positive, you get your point. The thing about this is that people will wonder where this came from. The f prime of 2, and f prime of 2 came from right up here. F prime of 2 is 4. Everything else was either you're just substituting in or you're given this. Also, I put these together. 4e to the 4th minus 6e to the 4th. It's like I had 4 bananas minus 6 bananas. I would have -2 bananas, of course. Duh. No, I'm just kidding. That's not a duh question, but why would I have -2 bananas? I don't know. I'm getting kind of tired. Can you tell by my comments? But keep on going, because that's what we do. The next one, we're considering this function. That's nice. We should always consider functions, each other's feelings, you know, other people in life. Consider this function. And given this information below, we answer the question. So I've got all this information. It's very nice. It's like a sign chart that I didn't actually have to do lots of work for. If you want to write it separately so that you can see, just if I just had f prime, then I would have -1 and 2 on it, and I've got the zeros there, you can. If you wanted to write it so you had f double prime, so I had 1/2 and the 0, and you can just see it goes negative, positive, you can. But I feel like I can go down and do the rest of this without doing that, so I'm going to. Okay, increasing and decreasing. Know that when you're looking at this, you're looking at f prime. So I justified it before I even put the intervals. I said f is increasing when f prime is greater than 0, decreasing when f prime is less than 0. And then what I did was I looked through the only place up here, I've got 2 zeros. I've got the 0 at -1 and at 2. So -infinity to -1, I can see that this is positive. From 2 to infinity, positive. Negative from -1 the entire way over to 2. I don't have to worry about this being 0 for the second derivative. If I'm classifying the relative extrema, that's just meaning relative min or relative max. So I can see positive to negative, and I draw this out. Positive to negative, positive slope to negative slope would be a relative max at x equals -1. A relative min, and I'm writing this. I'm not just saying it, the function. I'm saying f has a relative max as f prime. Be really careful about your justifications that you're actually telling me which function. Don't just say the function, its derivative, it, anything like that, because we've got f, f prime, f double prime. Also, if there's a g or an h or something else involved in the problem, make sure that you say those specifically. Okay, concavity would happen when, concave down would happen when the second derivative is negative. I wrote it out here. Concave up when f double prime is positive. Points of inflection happen when it changes. So this would actually be a point of inflection, and the reason would be because f double prime changes signs. It is not enough to say f double prime is equal to 0. Not good enough. You have to actually say changes from negative to positive or positive to negative, or changes signs. if you just say equals 0, I'm going to say, nope, not enough. And you can see this happens from negative infinity to 1/2 to positive infinity, if we're talking about less than 0, greater than 0 for f prime. If I'm determining the values of a and b in the equation of f, so the equation was given up above, this one. And so what I did was I take the first derivative, and then I took the second derivative. And the reason I did that, because if I take the second derivative, or really, yeah, here, the derivative of b is just going to be 0. So suddenly I don't have a b anymore. For this, you don't have to do the product rule or anything crazy because we are just using this as a coefficient. So this is an actual value. We can treat it as a number. So f double prime, that's the first thing I did, because I know if f has a point of inflection at x equals 1/2, remember that's what I just said, you go from negative to positive, point of inflection, but I can, for f of x, but f double prime is gonna be equal to 0. So I set this, f double prime, equal to 0. And I know it's when x is 1/2, so I put 1/2 in here. And I get 6 times, or 12 times 1/2, which is 6, I subtract, you know, whatever, get a is equal to -3. Then I can go back up to this f prime, and f prime of -1, up here, was equal to 0. You could have also used f prime of 2 would be equal to 0, and you get the same thing. But I just put a -1, and I solve this, and I can get b is equal to -12. And then you can also go back and check this too, and just make sure that this is right. And if I go back to my graph, I can substitute in, and I can say 2x to the third plus, and we did have ax squared, but we know a was -3. Oh, that looks weird. Plus bx, b was -12. And then if I graph it, I'm going to put this in a standard window of, I push zoom 6. And I can't quite see, so I'm going to go up a little bit more. My x, I'm going to go like -7 to 7, because it doesn't look like I used all of that. My x min and max, I'm going to increase a little bit, so nice. And I can actually see that this happens, and we can find the real values, but to make sure that we're right, let's see if this makes sense. From negative infinity to -1, f prime would be positive, meaning the slope is positive. Yep. And then I've got a horizontal tangent right here. Negative, negative, negative means decreasing, decreasing, decreasing until I get to 2. Decreasing, decreasing, decreasing until x equals 2. And then I've got positive, meaning f prime is positive, meaning f of x is increasing. So I'm all good with that one. Negative would be concave down to concave up. And it switches at x equals 1/2. So around here, concave down, concave up. Yes, I'm good. And that makes me happy when the answers work out like that. Okay, last thing. This one, go through, see what you can do, make sure that you've got these connections down. If you need to practice a few times, put a new piece of paper on this and then try it again. But all of these I went through, f of x is increasing. Some of these I think you'll get pretty quickly, some of them you'll have to think about. So like this one, pretty quickly, f of x is or f prime of x is positive, meaning the slope is positive. F of x is decreasing, the slope of f of x is negative. These ones we do a lot, so we've got change of signs, has a relative min or max, is positive. I'm going to go to one that I think, like these are still pretty regular. F of x has a point of inflection, f double prime changes signs. By the way, I'm saying, oh, these are pretty like normal ones that we do. That does not mean that they are easy. So make sure you know these connections. I think number 11 required the most thought when I was going through. I'm like, oh man, this is not something we ever do. If f prime has a point of inflection, I feel like I went like way deep here. And I'm thinking f triple prime, which is not something we do in calculus, but it is something that some people do in physics. If you're talking about jerk, not like a person in class who was like talking during a test or something, that is also a jerk, but that's not the same thing. Anyway, f prime has a point of inflection. F triple prime changes signs, which is pretty weird. But that also means that the second derivative, if I'm talking about changing signs, so the slope of the second derivative would be going from positive, or I'm sorry, the slope would be going from positive to negative, which means that I would have a min or a max. It's weird when I say slope because they're all slopes in some way. So f prime has a point of inflection, meaning 2 down from that. The third, f triple prime, changes signs. That means f double prime has a min or max. This is, again, going way deeper than you probably have to do, but all the other ones, so if that one like messes with your head, skip it, cross it out. But all the other ones, totally fair game. So make sure you know those. And you can do it. Study lots, ask me questions when you have them, whether it's via remind, email, or just coming to see me. But you can do this. Don't give up. I believe in you, and I'm super glad to be your teacher. So have a great night. And, well, I have no idea when you're studying this, but most people study pretty late at night, and it actually is at night when I'm recording this. So anyway, okay, bye.